Alright, thank you everyone for joining us today. My name is Stephen, and today our experiment will be building a simulation of a Mars rover, and effectively it will run also as a game. So we'll be using Scratch to do this. You don't need any experience. I will walk you through all of it. But hopefully you should have seen the document we sent you earlier this week. And so if you have gone through those steps in the document, your Scratch window should look something like this. And so throughout this presentation, I'll also be cutting from the slides to my window as well, so you can follow along. Feel free to pause this video if you need to rewind. And so here you should have both this helicopter sprite that you downloaded and a backdrop. And so if you don't have both of those, you should quickly run through the document again during our next few slides. So our objective today is really to go through the design process by effectively building our simulation step by step and then improving it based on our testing and observations. And so we're going to model how a payload, for instance, containing a drone or a robot or rover will land on the surface of Mars. And so this is obviously very important to do because you need to simulate what will happen to maybe tell the engineers to design something differently if something won't work out right before you actually perform the landing. So throughout this presentation then, I will be asking you to think of ways we can improve the simulation. So we'll all be contributing to making the simulation more accurate. Okay, so now going into our first step, we need to think about the factors we're going to build into our simulation. And so I'll give you time now to think about what factors we should consider in our code. So for starters, we'll obviously have to consider where the helicopter is and what direction it's going and how fast. Gravity, of course, perhaps wind. And so there are many other factors, and we'll build them gradually into our simulation. Okay, so to begin our simulation, we'll need to first put our helicopter in the right spot at the beginning of the simulation. And so to do this, we'll need to drag out this flag block. And so this can be found under events. And then we'll also need two of the position blocks under motion. And then we need to set the numbers to the right spot. The coordinates are -210 for x and 165 for y. So now that we have our position, now we need to consider how are we going to handle speed. So we want speed to be something you can adjust but not set. So like this works like a car. If you press the gas, it'll go faster, and over time it'll also slow down. So with a helicopter then, we can say you can accelerate to the right, to the left, or you can try and accelerate up. So slow down how fast you're falling. And so the first thing we need to do then is create variables. So in coding, these are very useful for storing information that will change over time. And so we can name them anything. In this case, we need to go to the variables tab, and then we need to make the variable. And so the name can be anything you want. I've chosen horizontal speed and vertical speed. And so once you go then to the variables tab, you can see I've already made them here, but if you need to make them, go to make a variable, type in the name. For all sprites, for this sprite only, it doesn't really matter, but just create it. And then now we're going to drag in our variables. So now we need to figure out how we use them. So the first thing to do is just like how we set our initial position at the beginning of the simulation, we also need to set our initial velocity. So we need to set our x speed and y speed. And generally, splitting our speed into two directions is very helpful when we're coding. So generally, we're probably going to be traveling pretty fast horizontally to the right, and we're also going to be going down at some speed. And so you can test what numbers feel right for you, but we can just use 150 and -20. So this will be 150 to the right and -20 down. So all we have to do then is just plug in these numbers. So now we have to figure out, how do we give the user control? So if we're going to make this like a game, then we'll have arrow keys. So you can use whatever keys you want, but I have set them to be arrow keys for now, and I'm going to use the right, up, and left arrow keys to change the speed of the helicopter. So we'll just need 3 sets of these blocks. And so basically, whenever these blocks are, whenever the right key is pressed, then the speed will be adjusted. So if it's a left or right arrow, then the horizontal speed will be increased or decreased, and so that'll be a nudge to the right or left, and then the up arrow will increase the vertical speed. So if it's already falling, it'll start to slow down a bit, but if it's going up, then it'll go up faster. So just drag the blocks in, and then adjust the numbers. I've tested that 5 seems like a pretty decent value, but you can set this to whatever value you want and test it. Okay, so now we need to actually adjust the movement. So we need to get our speed variables to affect our position. So you don't need to worry about the technical details of this block. All you have to do is copy it. The basic idea is that it splits the simulation into a bunch of intervals, and at each interval, it adjusts your position based on your speeds. So if your horizontal speed is very large, it'll adjust your position by a larger amount. And so Scratch also has this glide block, which is very helpful for us because it makes the motion look more smoothly. So all we have to do is insert these nested blocks inside each other, and then attach the forever loop to our main sequence. Okay, so now when we're building this, recall that we have to constantly test. So the first thing we have to test out is any errors we have, and then also test out what we need to improve and what we need to change. So click the green flag to test it, and so I will give you time now to make your observations about our simulation so far. So the first thing you'll notice is that if you click the up arrow enough times, the helicopter will begin to fly up, and then it will get stuck at the ceiling of the simulation. And so this means that we have forgotten to incorporate gravity. So then let's add gravity first, and then we can try testing again. So basically, in our forever loop, we want to constantly decrease our velocity, and this will represent the constant tug of Mars on the helicopter downwards, and so the vertical speed will always decrease. And so all we then have to do is change our vertical speed, and then I've set the value to -2, but you can change the value to whatever you feel is right. And again, you can repeatedly test this to see what number feels best for you. So then, before we move on to completing the simulation, let's first test it and see how it feels. And so, as you can see, the movement can be adjusted over time. by pressing the arrow keys over and over, so it does feel more realistic than before. Okay, so now to build our simulation, build an end into our simulation, so it will terminate at some point and won't run on forever. We're going to build a target, and so basically our landing will either be a pass or a fail, and so we'll say the landing is only a pass if it can hit the target, and so then we have to consider what the fail would be. So the fail could be if it hits the ground but not at the target, or if it goes out of bounds. And so for this, we'll say the landing is failed if the helicopter leaves the boundary of the simulation or hits the boundary of the simulation. So the first thing then we need to do is build the target. So we need to build a sprite, and so to do this, just go to the second blue circle in the corner and click paint. And so you can just drag some ovals. You can shade it in with whatever color you'd like. And you can make another oval inside it, and then you can shade it with a different color. Okay. And then you can adjust the circle however you'd like, and then you can also change the size to what you'd like it to be based on what you feel is the appropriate size. And then now we're going to do the same thing we did with the helicopter at the beginning of the simulation. So make sure we are on the right code tab first. So make sure sprite 1 is highlighted in blue in the sprite box, and then bring out the flag, and then set the coordinates again. And so the coordinates will be already set to default where you place it on your screen, but I've set it to 200 minus 130. And then finally, we need to get a purple block that says go to back layer, so it doesn't overlap the helicopter. Okay, so now we're going back to the helicopter, and we need to check if it touches the landing pad. And so to do this, we need to use a conditional, or an if statement. So in the control block, in the control section, we need an if block, and then Scratch actually has a built-in conditional called touching color. And so we use the dropper function, grab the center ring's color, and then that's our conditional. So if it's touching that color, then we can stop the simulation by going to control and getting a stop all block. Okay, now we need to build, that's a successful landing. Now we need to check if it's a failed landing. So we said earlier that a failed landing is if it goes out of bounds. So to check if it's out of bounds, we need to use its coordinates. So we're going to build this very large conditional block to check. So basically you can see if X position is outside the bounds of 210 to negative 210, and the Y position is out of the bounds of 170 or negative 170, which is the boundary of our simulation screen, then we can end the simulation here. So building it, basically you need to nest 3 OR blocks, two in the spaces of the first block, just like this, and then 2 in each pair. It should be 1 less and 1 greater, and then you'll need 2 X positions and 2 Y positions. And then the coordinates for X are 210 and minus 210. Minus 170 and 170. Okay, and then we can just add this to our main sequence inside the forever loop because we want to constantly check if it's out of bounds, and then we can stop all. So now we've built the finish in, so now let's test it. Okay, so it seems to work. If we run into the boundary, it fails, but if it lands in the circle, it succeeds. So now our goal is to find any errors we have that need to be patched up, or any improvements we can make. So the first thing we can see is that our circle is not actually completely on the screen, and so we might want to adjust the coordinates for that. That's one instance of a fix we can do. Okay, but errors aside, now we want to improve our simulation, even make it even more accurate. So what factors can we include in our simulation to make it more realistic? And so here are some ideas, but you should come up with one or two of your own. So first is, you can't really tell if you've succeeded or failed very directly. You have to look if you're kind of in the target or not. So the first thing to do is put some text on the screen saying if it was a pass or a fail. And so to do this, you'll need a new sprites, and then you can try using the costumes feature. Consider wind. Of course, on Mars, because of the atmosphere on Mars, the wind is not really as big of a deal, but you can try incorporating wind to as practice. And so before we finish, I'll let you look at my simulation, which I've incorporated a couple of factors. So for instance, I have included a fuel, so that limits the amount of times you can press the arrows. I have included a wind, which is random every time in the simulation. I've included a parachute, so when you press space, the helicopter slows down very significantly. And then I've also put another condition on the successful landing, in that it has to be slow enough. So if it hits the landing pad too fast, it'll be considered failed. So we can take a look here. So that's the parachute. So you see it slows down a lot. And then you see if it hits the landing pad too fast, it'll be considered a fail. And you can also see the fuel going down as I press. And so there, if it's slow enough, it'll be considered a success. So you can try and break down what I've included in this improved simulation and try and incorporate it in your own. And you should also share your ideas and how you would implement them as well. Alright, that's all we have for today. Thank you for joining us.